All right, so hey guys, what's up? This is a video over dilutions. So there's two different ways you can do dilutions. One way is to understand what you're doing, and the second way is to use the molarity equation. Now, you can use the molarity equation and know what's happening and know what you're doing. But there are some times when information is given to you, and there's no need to use the molarity equation. The dilution equation. So it's really up to you. I don't care which way you do it. I'm going to work a couple of these both ways so that you can see it, and hopefully you at least understand what's happening. The dilution equation is M1 V1 is equal to M2 V2. And basically what a dilution is, hopefully you know this, is when you add solvent. And so you're making a solution less concentrated. Solution, abbreviation for solution, less concentrated. Sometimes people would say you're making it dilute. So like if you take concentrated frozen orange juice and you put it in a pitcher and you add a bunch of water to it, you're diluting the orange juice. But the main thing that you have to know about dilutions is that if you have molarity, which is moles over liters, and you multiply it times volume, which is liters, all you really have is moles. And so you're doing this on both sides. So what it's saying is that the moles before the dilution is equal to the moles after the dilution. And that makes sense, because if you have a container of salt water and you add water to it, the number of moles of salt isn't changing. So the moles stayed the same throughout the whole dilution. The only thing that changed was the volume. And so it made it less concentrated because the volume in your molarity went up, and so it makes the whole molarity come down. So let's work a few examples and see how it goes. Okay, so I wrote the dilution equation up there just so that it would be visible to you while we work through this. And it says, what is the molarity of a solution after 200 milliliters of a 6 molar hydrochloric acid solution is mixed with 100 milliliters of water? So basically what we have is we have a container, right, with 200 milliliters in it of 6 molar HCl, and then we're going to dump in here 100 extra milliliters of water, so it's going to go up by 100 milliliters, the volume will. And so by doing that, we've increased the volume, and so this should go down. So I'm going to first solve this without using the dilution equation, and then I'm going to solve it with using the dilution equation, and you can do either one. All right, so I'm just going to move this up. Okay, so before the dilution, I have 200 milliliters of a 6 molar solution. So I know that tells me I've got 0.2 liters, right, and 6.0 moles per liter. So if a dilution is the moles before is equal to the moles after, then I just need to find the moles first. So liters and liters will cancel out, and I've got 1.2 moles. And that's how many moles will stay constant of hydrochloric acid in this solution. Now, after the dilution, I need to take my moles and find my new molarity. And so if this is my moles that's constant, what's my new volume? I had 200 milliliters of a solution, and I added to that 100 milliliters of water. So my new volume is 300 milliliters total. So if I take my 1.2 moles that I got up here and I use it here and I divide by my new volume of 0.3 liters, right, because this is 0.3 liters, then that would give me 4 moles in every liter. And so that's my new concentration. Okay? So I found the moles that's in the solution of the hydrochloric acid, and then I divided by my new volume, which gave me my new molarity. So if I want to use the dilution equation, then I am going to plug in my first volume and my first molarity So before the dilution over here and then after the dilution over here. And honestly, it doesn't matter which side you plug it into as long as the right volume is with the right molarity. So I'm going to come back up here so we can see the problem and label these. So this would be V1 and this would be M1. And then I'm looking for M2. And V2 would be my new total volume, which would be 300 milliliters. Okay, and so when I said they had to go together, this right here, it says milliliters of a 6 molar. So since this volume is related to, you can't see that, this volume is related to this molarity, and so they have to be both either M1 and V1 or M2 and V2. Okay, so I'm going to go back down here and plug all that in. So I've got 6 molar for my M1. V1 is going to be 200 milliliters, and I can leave it in milliliters. M2 is what I'm looking for, and my V2 is 300 because that's my new total volume, right? So that's one place where students make a lot of mistakes, is that they don't use 300, they would put 100 here. You have to use the new total volume. Oops. Okay, so I'm going to divide both sides by 300. So that cancels out. So I'm going to take 6 times 2, which would be 1200, times 300, or divided by 300, gives me 4 molar. And so that's my second molarity, which is the exact same thing we got up here. So it doesn't really matter which way you go. Sometimes you're doing more work one way or the other, but just make sure that you're able to do it whichever way that you choose. Okay. So, all right, in this problem we have, to what volume must a solution of 50 grams of sulfuric acid and 300 milliliters of solution be diluted to give a 0.1 molar solution? So I'm going to start with 50 grams, and it's in 300 milliliters of solution, and I want my new molarity to be 0.1. And I'm looking for my volume of this solution. That's what I'm looking for. So the first thing I have to do is I have to find the number of moles in the beginning. So in the beginning, all I have is 50 grams of H2SO4. So to find the number of moles, 98 grams and 1 mole for sulfuric acid. And 50 divided by 98 is 0.51 moles. All right, so that's how many moles that I have. Okay, so that's not going to change, right? And so to find my new molarity at the end, I would divide by my new volume, right? Well, I don't want my new molarity, I want my new volume. So I need to take my new molarity and I'm going to divide by it. So there's 0.1 moles in every single liter, right? So this is going to give me 5.1 liters. And that's how I would approach this problem. This 300 milliliters that's given to you in the problem, that really doesn't even matter. But if we use the dilution equation, I need to find my M1 because I don't have it. All I know is that there's 50 grams in 300 milliliters, so I can find it from that information. My V1 is going to be the 300 milliliters. M2 is 0.1 molar, and V2 is what we're looking for. Okay, so again, I'm going to find my moles, take 50 grams of sulfuric acid, divide by 98 grams per mole, and that gives me 0.51 moles. I'm going to divide that by 0.3 liters, which will give me 1.7 molarity solution, or 1.7 molar solution. Okay, so then from there, I can plug this in as M1. So now I have everything that I need to be able to solve for V2. So 1.7 molar times 300 milliliters is equal to 0.10 molar times V2. So I'm going to divide both sides by 0.1. And I end up with 5,100 milliliters. So V2 is equal to 5,100 milliliters. Now up here I got 5.1 liters, and down here I got 5,100 milliliters. So they're both exactly the same thing, and it didn't say which one which unit we needed to find it in. So, like I said, if you understand that what you have at the moles that you have in the beginning has to be equal to the moles that you have at the end, then all you got to do is get the moles in the beginning and divide by your new volume, or do something with it to get what you want. If you can't think that way, that's fine. Just stick everything into the equation. Sometimes you may do a little bit more work. This took a little more work than that did, because we divided by 0.3 here to get the molarity, to plug it into this, and then we multiplied by 0.3. Or 300 milliliters, which is the same thing. So sometimes it's a little bit more work. If you divide by it and multiply by it, then it's just canceled out. And that's why up here, in this part of the problem right here, where is it? We had moles and we just divided by the molarity to get liters. We didn't have to do anything with the 300 in this part. Okay. So number 3, how many milliliters of H2O must be added to 150 milliliters of a 1.4 molar hydrochloric acid to make a solution that is 0.5 molar HCl? So this problem can be a little tricky, but let's go ahead and solve for it. So I'm going to find my initial moles. So underlined in green is my initial amounts, and then in blue is my final amounts. So I'm going to find my moles initially. So I'm going to take 0.15 liters, because that's this, right? If I move the decimal over, I can get rid of milli, times 1.40 moles per liter. And so this would be my initial moles. So 0.15 times 1.4 is equal to 0.21 moles. So this is how many moles it's going to be constantly. So then I can take my moles that I have in the solution and divide by 0.50 moles in every liter, because this is the after, right? It's the final. So moles cancels out. So 0.21 divided by 0.5 is equal to 0.42 liters. So this is my V2, my final volume. This question doesn't ask for that, though. It asks for how many milliliters of water do I have to add. So I started out with 0.15 liters, or let's rewrite that, as 150 milliliters is where I started. And I finished, my volume is 420 milliliters. So 420 milliliters minus 150, the difference between those is 270 milliliters. So that's how much water I had to add. Whoops. Doesn't help much if I don't change back to a pen. Had to add 270 milliliters to 150 milliliters to get to 420 milliliters total. All right. Sometimes I write too fast and then the iPad doesn't know what I'm writing anymore and it stops reading my pen. Like right now. Okay. So you could also use the dilution equation. You plug everything in. So I'm going to go back up here and look at this problem and label everything as what it should be. So 150 milliliters, that's going to be V1. This one is V2. Or I'm sorry, M1. What am I doing? Not paying attention. M1. This one right here is M2. So I look for V2, right? So I've got 150 milliliters, V1. My M1 is 1.4, and then that's going to be equal to 0.5 molar times V2. So if I do that, I get, let's see, 150 times 1.4 divided by 0.5, 420. So that cancels, molarity cancels, and I end up with 420, dang it, milliliters total. And still you'd have to take 420 milliliters minus what you started at 150 to get 270 milliliters added. All right, let's do one more, and then I'm going to work a different kind of problem after that. Okay, how would you prepare 4 liters of 0.5 molar sodium carbonate from a 5 molar stock solution? And I put this on here because 1, it says how would you prepare? That's descriptive. And 2, it has this weird word stock solution. Stock solution just means what you have in stock. It's usually a concentrated solution that you're going to use, and you're going to dilute it down to lower concentration so that you get more for your money. That's pretty much how we do most of the labs here. I buy something at a very high concentration, and then I dilute it down to a very low concentration for you guys to use safely. All right, so I'm just going to use the dilution equation with this. So I've got, first of all, which one's going to be M1? A lot of students would pick this as M1, and that's fine, you can, as long as this is V1. But what I want you to remember is that that's the ones that have the arrows in blue, this and this, that's the end. That's not the beginning. This is the final solution because it's the diluted solution. We made that from this. So we start with this and then we make these. All right, so I'm going to say that these are M2 and V2, but you could use M1 and V1. It's not going to change your answer because both sides of the equation are exactly the same thing. All right, so I've got 5. So this, of course, is going to be M1, and we're looking for V1. So 5.0 molar times a volume is equal to 0.5 molar times 4.0 liters. So if I take 0.5 times 4, and then I'm going to divide by 5. Molarity cancels out. So 0.5 times 4 is 2, divided by 5 is, what is that, 0.4, I think? Yeah. Yeah, duh. I'm just going to move decimals around. I can see that. Okay, so V2 is that. 0.4 liters. But now we have to answer the question, how would you prepare it? And so remember how I said that the right volume had to stick with the right molarity? This says 4 liters of this solution. Well, that means that this volume is of that solution. So I'm going to describe this like this. Take 0.4 liters of 5 molar solution and dilute it to 4 liters of solution. So if we do that, we should get a solution that's 0.5 molar, which is what we want, because that's our second V. And so you could put add 3.6 liters of water, because that's the difference between these two volumes. So we're adding 3.6 liters to 0.4 liters of a 5 molar solution. All right. Okay, this last problem is a little bit different. There's one of these on your quest, and there's one of these on the worksheet that I gave you in class. So I want you to find the concentration if I have 100 milliliters of a 0.23 molar HCl solution, and I add to that 200 milliliters of 0.10 molar HCl solution. So find the concentration of HCl in the final solution, basically, is what I want you to find. And so if you look at this problem, you should be able to say, well, this solution is going to get stronger, and this solution is going to get weaker, because we're adding a weaker solution to this stronger solution. And so we're diluting this one. So what I have to do is if I want to find concentration, concentration is moles of the solute, which would be HCl in this part, divided by the total volume of the solution. So I have to find the moles of the solute, and then I have to divide by my total volume. So the first thing I'm going to do, I'm going to label this as solution 1 and this one as solution 2. So in solution 1, I have 0.100 liters of solution, and there's 0.23 moles of this solution in every liter. So that's going to cancel out. So 0.1 times 0.23 is 0.023 moles of HCl. That's the first solution. Okay, in the second solution, I've got 0.200 liters, and it's 0.10 moles in every liter. And so that's 0.02 moles of HCl. So my total number of moles is the sum of those two. It's going to be 0.023 plus 0.02. So that's 0.043 moles in total. And we expect the concentration of this solution to be right in between, somewhere in between these two solutions, okay? Probably closer to the 0.1 because we're adding more of the 0.1. Okay, so if that's my total moles, now I have to divide by the total volume of the solution. And so the total volume of the solution is going to be 300 milliliters because I'm adding all of this together. So I've got 300 milliliters total. So I'm going to divide this by 0.300 liters. So 0.043 divided by 0.3 comes out to 0.1433. So my new molarity is 0.143 molar. That's my new molarity of the solution, which is right in between 0.223 and 0.1. It's a little closer to the 0.1. All right, so that's how you do this. You need to work a bunch of problems, and it'll get easier once you start seeing the different ways the questions are asked.